Hello, good morning everyone. The previous class is discussion about Kirchhoff's laws. There are two different laws of Kirchhoff's laws, Kirchhoff First Law and Kirchhoff Second Law. The Kirchhoff First Law is called First Law. The Kirchhoff First Law is called Kirchhoff Current Law. That is also called Current Law. That is also called Node Law and Junction Law. This is the different names of the types of different names of a Kirchhoff first law. According to the law states that the algebraic sum of the currents in a electrical network must be is equal to 0 at a node is called Kirchhoff first law. That means the summation I is equal to 0. Expand this equation. The first current 1 is a converging current I2 is a diverging current, plus I3 is a converging current, minus I4 is equal to diverging current. Negative sign indicates that diverging, the positive sign indicates that is a converging current. That is a algebraic sum of the currents must be is equal to 0. That is the Kirchhoff first law. And the Kirchhoff second law means, that is also called Kirchhoff voltage law. The Kirchhoff first law is based on the work of, it works on the principle of law of conservation of charges. That is this point is very important. Okay now. Next second law is, that is also called Kirchhoff voltage law. That is also called voltage law and loop law. Loop means what? What is the meaning of node? The any two conductors are contact. That position is called a node. Loop means it is the electrical network is a closed path. Now the Kirchhoff first law is depends on open loop. The Kirchhoff second law is depends on the closed loop. It is a loop means the electrical network is a closed path. That is called Kirchhoff voltage law. That is also called mesh law. Mesh, M-E-S-H, mesh. Okay now. This according to this law states that in the electrical network, the algebraic sum of the EMF of a cells, the electrical network, the algebraic sum of the EMF of cells must be is equal to the algebraic sum of the product of current and resistance. The product of current and resistance in the loop. That is the Kirchhoff's second law statement. That is the summation E is equal to summation IR. That is the equation. Expand this equation. The E1 is a converging current minus E2 is a diverging current plus E3 is a what? That is a converging current. The product of current and resistance means that is a I1 R1. It is a converging. I2 R2 is diverging plus I3 R3 is a converging. This is the expansion of a Kirchhoff voltage law. This is the laws of Kirchhoff first and second law. And the Kirchhoff second law is based on the principle of law of conservation of energy. That point is also important. Law of conservation of energy. Law of conservation of energy. This is the concept of Kirchhoff's law. By using a Kirchhoff's law, what is the relation between resistors? That means that is also called Wheatstone network. Wheatstone network. That is the one of the experiment in your laboratory. That is a meter gauge. The meter gauge is a electronic board. It is used to measure the balancing length of a given resistance. That means the meter gauge works on the principle of, that is a Wheatstone network. First of all, what is the meaning of Wheatstone network? The Wheatstone network means the arrangement of four resistors. It is used to compare the two unknown resistors. And the one of the resistance is given value. That is a known value. One of the resistance is known value. Find the other value of a resistance. That is the meaning of Wheatstone network. It is a quadrilateral shape. The shape of the Wheatstone network is quadrilateral shape. It is consists of four resistors, and it is also consists of one conductor is galvanometer. By using a Kirchhoff first law and second law, Kirchhoff current law and Kirchhoff at a node one position, Similarly, by using a Kirchhoff current law at a node, one more node, calculate the I1 and I2 values. By using a Kirchhoff voltage law and two different loops, solving this equation finally will get the relation between PQ or is called relations between the this Wheatstone network, that is a P by Q is equal to R by S. That is the relation between the resistors. This is the final equation. This is also principle of the meter bridge. P by Q is equal to R by S is the principle of the Wheatstone network. This is the concept of Wheatstone bridge, Wheatstone bridge or meter bridge. And the one more concept is, now previous classes already discussion about what is the concept of EMF. Cell, that is also called cell, battery. Cell means it is an electronic device, electronic element. It is an electronic device which provides the necessary current in the circuit. Particular potential, that is a 2 volts, 5 volts, 8 volts. Some particular potential is applied, that is called cell. The EMF cell means, that is the EMF cell is defined as the work done unit positive charges. The work done drive the positive charges of external resistance. The work done drive the positive charges of internal resistance. That is the small r is the symbol of the internal resistance. The capital R is the external resistance. That is the relation is the EMF cell says, that is E is equal to the equation is the small capital R is a resistance, the current is as it is. The small r is a internal resistance, the current is as it is. That is a common factor. What is the common factor? The current common factor. This is the expression for what EMF of a cell. The common factor is capital I, current is common factor, that is take outside, that is R plus small r. Find the capital I. The capital I is equal to the EMF of a cell divided by R plus R. This is the expression for current in a circuit. I is equal to E by R plus R. There is a expression for current in a circuit. That is a E is a EMF of a cell, capital R is the external resistance, small r is a internal resistance, and I is a current through the circuit. This is the concept. Okay na? In the previous classes, what is the meaning of internal resistance? Internal resistance means it is a opposition offered by the cell. The flow of charges. The opposition offered by the cell. The flow of charges. That is the one of the part of resistance. That is the one of the part of resistance. Okay na? This is the called internal resistance. Then the combination of cells. There are two different types of combination of cells. First one is the two cells are connected in series. That is the one of the type. That is a combination in the combination of cells in series. The combination of cells. Combination of a next concept is combination. The combination of a cells. One is it is classified into two different types. The cells are connected in series combination. The cells are connected in parallel combination. First, series combination. Series combination. This is the symbol of this cell. That is a cell. That is a one. It is consists of two conductors. One is a positive charge, another one is negative charge. One conductor is big, another conductor is small. It is parallel to each other. That is the symbol of a EMF cell or battery cell. Battery. It is also called potential difference. My question is, what is the expression for the effective EMF? Effective EMF. EMF means cell. What is the expression for the effective EMF? That is E. And internal resistance. Internal resistance means the symbol is small r. Of a two cells, they are connected in series. That is the question. How to derive the expression for the effective EMF of a cells and internal resistance of a cell also are connected in series combination. First to draw the circuit diagram. The two cells, this is a one cell, this is called one more cell, E1 is called first cell, E2 is called second cell. It is a two different positions A and B. This is a one more position B and C. This is the two cells are connected in series combination. The internal resistance of a first cell is R1. The internal resistance of a second cell is R2. And the combination of a cells is, there is a combining of a cells. The combination of a two cells is replaced by a single cell, that is called effective EMF of a cell. Effective EMF of a cell, that is a single cell. What is the symbol of the equivalent EMF of a cell? E equivalent. E equivalent. It is a one terminal is A, another terminal is C, final terminal is C. R equivalent. The R equivalent equal internal resistance. Equivalent internal resistance of a cells. This is the circuit diagram of a combination of a two cells. Consider the two cells are connected in series combination, that is E1, E2 be the EMF of a cells, R1, R2 be the internal resistance of a cells with respectively. In series combination, the current remains same. The potential will be divides. The potential is divides. The current is as it is. The current is a same. Constant. Current is a constant. The potential difference is different. That means the potential difference of a first cell is V1. The potential difference of a second cell is V2. The current is, main current is same. The same current is the same. According to in previous expression is the terminal potential difference. The terminal potential difference, what is the equation? That is by using the EMF of a cell equation, that is E is equal to I capital R, small r capital I. According to Ohm's law, IR is equal to potential difference plus I small r. Find the value of V. V is equal to EMF of cell minus IR. That is a terminal potential. V is equal to EMF of a cell minus I small r. This is the terminal potential. Terminal potential. Then my question is, first, what is the potential of a first cell? What is the potential difference of a second cell? The potential difference of the potential or the terminal potential difference of a first cell is given by the potential difference is E1. Comparing this equation, the first cell is E1, the current is, main current is same, the internal resistance is small r1 across AB, across AB. And similarly, the potential difference of second cell, the potential difference of a second cell is, that is V2 is equal to, the second cell is E2, the main current is capital I, the internal resistance is R2 across the BC, along BC. See, first to find potential difference of first cell, potential difference of a second cell. That means what is the total potential difference of in this circuit? Then that is also called net potential. The net potential difference of a along AC is given by sum of the potentials. The total potential along AC is given by V is equal to sum of the potentials, that is V is equal to V1 plus V2. Substitute the values of the above values is V1, V2, substitute in this equation. Therefore, V is equal to what is the V1? That is the E1 minus I R1 by using a brackets plus V2 is E2 minus I R2. Simplify in this equation. My mathematical simplification. V is equal to E1 minus I R1 plus into plus is plus E2 plus into minus is minus capital I R2, or the total potential V is equal to see the E1 minus E2 or E1 plus E2, the minus sign and the second term and the fourth term compare. The main current is as it is, the sign is negative, main current is same. That is, take common factor minus I is a common factor, remaining R1 plus R2. That is the total potential. The total potential along a AC circuit is V is equal to sum of the cells minus sum of the resistors. That is the one equation. That is called equation number 1. See, the circuit diagram shows the combination of a cells. The combination of a cells is replaced by a single cell. The combination of internal resistors are replaced by a single equivalent resistor. Single resistors. That is called equivalent EMF of a cell. Equivalent EMF of a cell, or that is also called effective EMF of a cell. Effective and equivalent both are same. Then what is the terminal potential difference? Comparing this equation, comparing to in this diagram, the potential difference is V, the current is I, the potential difference, the effective EMF of a cell is given by, that is a E equivalent. That is a E equivalent means effective EMF of a cell, or equivalent of a internal resistance of a cell. This equation is comparing to second circuit, that is the potential difference is V, the cell is E equivalent, the main current is I, the main current in this diagram, main current is as it is, and the internal resistance is R equivalent. That is called equation number 2. Comparing equation 1 and 2, in the LHS side is potential difference both are same. That is a cancel. Comparing equations 1 and 2, we get the LHS sides, the potential difference same as it is same, that cancel. Then the RHS sides, the E equivalent is equal to sum of the cells. That is a E equivalent is equal to E1 plus E2. That is the one equation. That is called, this equation is called equation number 3. The equation number 3 is called, this is the expression for effective EMF of a cells in series combination. The effective EMF of cells means, that is the conclusion of this equation is, the effective EMF of a cells must be is equal to sum of the individual cells. Then second terms, comparing second terms, minus I, both sides get cancelled. Then remaining is what? R equivalent is equal to R1 plus R2. R equivalent is equal to R1 plus R2. This is called expression for internal resistance of a two cells. The effective internal resistance of a two cells. That is R equivalent is equal to R1 plus R2. The conclusion of in this equation is, the effective or the equivalent internal resistance of a cell must be is equal to sum of the individual resistors, internal resistors. This is called equation number 4. The equation number 3 is called, that is the expression for effective EMF of a cells in series combination. The equation number 4 is called the effective internal resistance of a two cells are connected in series combination. This is the concept of effective EMF and internal resistance are connected in. This is the expression for effective EMF and internal resistance. The combination of two cells are connected in series. This is the series combination. This is a 5 marks question, is very important. Question and problems also very important in this concept. Once again, listen. First, the combination of cells. There are two different combination of cells. It is first one is series combination. Second one is parallel combination. Series combination means it is two cells are connected in series. It is said to be series combination. It is connected in two. What is it? Series. It is connected in two cells are connected in series combination. The current is same and the potential difference is different. The potential difference is different. That is the definition of series combination of cells. First, to draw the combination of cells, E1, E2 be the combination of cells. The main current is I. R1, R2 be the internal resistors. E1, E2 be the cells. The combination of cells is replaced by a single cell, that is called effective EMF of a cell. Equivalent EMF of a cell. The current is main current is I. The potential difference is V. E equivalent means cell, or equivalent means equivalent internal resistance of a cell. By using a terminal potential definition, that is V is equal to epsilon minus IR. That is the potential difference. The potential, first to write the potential difference of a first cell, then similarly the potential difference of a second cell. First cell is V1 is equal to cell minus main current internal resistance. The potential difference of a second cell is V2. The potential difference is V2. The cell is E2. Main current is I. The internal resistance is R2 along BC. After the V1, V2, then find out the total potential difference. The total potential difference is equal to, that is a sum of the individual potentials. Simplify. Substitute the values of V1 and V2. Simplify. Finally, we'll get, that is the V is equal to sum of the cells is E1, E2 minus I. Minus I is a common factor, that is take outside, R1 plus R2. That is called equation number 2. That is the first diagram equation. The second diagram circuit shows, see, the combination of a cells is replaced by a single cell, that is called effective EMF of a cell, equivalent EMF of a cell. That is the equation is V is equal to E equivalent minus I or equivalent. Comparing equation 1 and 2, the both sides of potential get cancelled. The RHS part is comparing two equations. The E equivalent is equal to sum of the cells. The R equivalent is equal to sum of the internal resistors. This is the expression for the equivalent EMF of a cells and internal resistance of a cells. This is the series combination. Next one is parallel combination. Second type. Parallel combination. Parallel combination. Parallel combination means the two cells are said to be parallel. It is connected between two different terminals. The current is different. The potential difference is same. The current is different. The potential difference is same. That is the meaning of the parallel combination of cells. Parallel combination of a cells. First to draw this circuit, see, that is the first cell, this is called second cell. The two cells are connected in parallel direction. E1 is the first cell, E2 is the second cell. The internal resistance of a first cell is R1. The internal resistance of a second cell is R2. The current flowing through the first cell is I1. The current flowing through the second cell is I2. That's the main current, I. Okay, now that is the A terminal. This is called B terminal. This is called C terminal. This is called D terminal. Then this combination of a cells is replaced by a single cell. The combination of these cells is replaced by a single cell. That is a cell. Single cell. E equivalent or equivalent. E equivalent or equivalent, A terminal and D terminal. The current is I. The current flowing through the circuit is capital I. This is the definition and circuit diagram and explanation of a parallel combination. Once again, the parallel combination means if two cells, the two or more cells are said to be parallel combination, it is connected between two different terminals. The current is different, the potential difference is constant. That is called what? The series combination, parallel combination of a cells. Then the two cells diagram, the two cells are connected in parallel to each other. The I1, I2 be the two different currents. The E1, E2 be the two cells is connected parallel to each other. The R1, R2 is the internal resistance of a cell. It is this combination is replaced by a single cell, that is called E equivalent. The current is same, the potential difference is V. First, as it is same, by using a terminal potential difference, the terminal potential difference means by using a Ohm's law, V is equal to the cell is epsilon, current is main current is I, internal resistance is small r. In the cell, the potential difference of this circuit is same. That means the potential difference is same. The potential difference of in the circuit is same. The first cell is E1. The current flowing through the first cell is I1. The internal resistance is R1. The internal resistance is R1. That is a potential of a first cell. Find the value of main current. Not main current. First current. The current flowing through the first cell I1. That is I1 R1 is equal to E1 minus V, or I1 is equal to the E1 minus V divided by R1. It is a current flowing through a first cell. I1 is equal to E1 minus V divided by R1. Then similarly, find out the value of I2 as it is same. Second cell means what is the cell? That is E2. The potential difference is same. Divided by internal resistance is R2. That is the I2. That is called I2. Then find out the total current. The total current flowing through in this circuit. Net current, that is a net current is equal to sum of the currents I1 plus I2. The net current is equal to sum of the currents. Okay, now then substitute the values of I1 and I2. We'll get, that is the equation. That equation is called that is the first circuit. That equation is called shows the first circuit equation. Once again, the parallel combination means, first, what is the meaning of parallel combination? It is a two or more cells are said to be parallel. The current is flowing through the each cell is different and potential difference is same. That is a parallel combination. The series combination means, what is the meaning of series combination? It is a two cells or two or more cells are said to be series combination. It is connected in same different positions. It is the current is same and potential difference is different. This is the difference between series and parallel combination. Okay, continue to in this derivation next class. Okay, thank you.